This is a basic optimization problem regarding product and minimum sum. The product of two positive integers x and y is 625, so this is easy, right? 6 multiply y equals to 625. You have to tell me what x and y are such that their sum is minimized. So you have two numbers, x times y equals to 625. You might be thinking, all right, there are plenty of different combination, right? Let's say 1 times 625, and then 5 times another value equals to 625, so on and so forth. So there are many different combinations. So which combination has the minimum sum? Of course, we are not trying to do like guessing. So the way to solve optimization problem to begin with, you have to define the variable. So in this problem, I already defined them for you, x and y, right? Two positive numbers. And then you have to write two equation, one primary and one secondary. So what is a primary equation? So primary, how about primary function? Let's don't use the word equation. Primary function. So the primary is what the problem is asking. The problem is asking for the sum, a minimized sum. So I'm going to say the sum is equals to x plus y, and then you leave this alone for a little bit, and then you move on to the secondary. So the secondary function is what is given. So the given condition is you have two positive integers, x and y, and their product is 625. So for the secondary, let me use a different color. So for the secondary function, this is about the what? This is about the product, right? So I'm going to say the product is equals to x times y, and then we plug in what we already know. So we have 625 equals to x times y, and then I am going to express this as y in terms of x. So y is equals to 625 divided by x. Why do we have to do this? Because I am going to substitute the secondary to a primary. So after the substitution, the primary becomes s equals to x plus y is now 625 divided by x. And then this, I'm not going to call that s equals to, I'm going to call that s of x. So the s is the sum function, and then x is the independent variable. So this is one function in terms of one independent variable. Why do we have to do a substitution? Because we are trying to minimize, right? Do you still remember the lesson where we talking about the the relative or local minimum? So the concept is we will have to use the first derivative test. So we take the derivative of a function and then set that equals to 0. We use a first derivative equals to 0 because at the maximum and minimum, there is a horizontal tangent line. So that's why we set the first derivative equals to 0. And then we look for the critical numbers or critical values, and then we set up a test interval and then test the interval to see if the critical number or value is a minimum or a maximum. So we do the same thing in here. So we are trying to put that concept on an application. So the next step is you take the derivative. So in this type of problem, the hardest part is to set up the function. So after the setup and the substitution, the derivative and the critical number, usually they are pretty easy. All right, usually the derivative, the critical number, they are pretty easy. The hardest part is the primary and the secondary function. All right, so we have s prime of x equals to the derivative of x is equals to 1, so that is 625 times x to the negative 1. We bring the negative 1 down, so the negative 1 becomes a negative 2, so we subtract 625 divided by x squared, and then we have to set that equals to 0. Why? Because we are looking for the minimum or maximum at that point. Think about the graph of min and max. At that point, there is a horizontal tangent, so therefore the slope is equals to 0. And then you are trying to solve for x, so we move the 625 to the other side, so 625 divided by x squared, and then you multiply both sides by x squared equals to 625, and then you take the square root on both sides. So what is x equals to? So x equals to the square root of 625. Where is the plus or minus? We do not use the plus or minus because we use positive integer. The problem said we have two positive integers, right? So positive, we only keep the positive. So x is equals to 25, right? So x is equals to 25. And then what else? So when x is equals to 25, we have x equals to 25. This is a critical number. And then what is y equal to? Y is equals to 625 divided by 25. Oh, it looks like y is also equal to 25. So y is also equals to 25. And then are we done? We are not. We are not done at all. What are we looking for? We are looking for a minimum sum, right? The sum is minimized. How do you know that when x equals to 25, the sum is minimized? Easy. So we will have to prove that at x equals to 25, there is a minimum. So we are going to draw a number line. And then we do this. So we have a 25 right over here. So we have a 0. And then I'm going to block this off because we are not considering any negative integers. All right. So this is from 0 to 25. And then this is from 25. I will say that is up to 625. 625 because for positive integer is one of the factor is greater than 625, there is no way to get a product of 625. So I would say up to 625. So this one, pick something easy to test, pick something easy to test, and then you will be testing the first derivative. So s prime of 1. So what is that equal to? That is 1 divided by 625 divided by 1 square. That is less than 0. And then when you test s prime of 26, this is 1 minus 625 divided by 26 square. That one is greater than 0. Okay, so what do we see here? So first derivative less than 0, the slope is decreasing, right? And then first derivative greater than 0, the slope is decreasing. So we have decrease and then increase, so such that x equals to 25 is a minimum. So we just proved that when x equals to 25, there is a minimum. And then what else do we write? So we have x equals to 25, y equals to 25. So the product is equals to 25 times 25, which is equals to 625. And the minimum sum, what is that equal to? You add them, right? So 25 plus 25, that is equals to 50. That is the minimum sum. And then you might be thinking, right, for the absolute minimum and maximum, how about the 2n? So what do I mean the 2n? Let's say x equals to 0. Can x be equal to 0? When x is equals to 0, that doesn't make any sense because when x equals to 0, you have 625. So 625 equals to 0 times y. This doesn't make any sense. And then how about x equals to 625? Then this must be 625 equals to 625 times 1. But then the sum will be 625 plus 1, which is way too big. All right. So based on everything we just did, we can prove that when x is equals to 25, the sum of these two positive numbers is minimized, and that is the end of this problem. So if you like it, you like the way I solve optimization problem, give me a like, share the video for me, click the subscribe button if you are new to the channel. Truly appreciate your help. I will see you all in the next optimization problem. Signing out.